I hope you're alive. Yep, we're live. Hey, what's up, guys? Welcome to another stream. Welcome to the third stream, I believe. Yeah, this is the third stream. Welcome to the third stream in this OpenGL 2D game engine, illus2D engine series. This video going to be finally delving into mathematics. This is going to be a really fun. This is going to be a really fun stream, guys. I'm going to just tell you already because we're finally going to be getting into mathematics. Now, mathematics is really important for graphics programming. Anything you see, any video games you play, any animation you watch has a lot of mathematical calculations happening in the background, which is usually just some linear algebra calculation like vector multiplication, vector matrix multiplication, and stuff like those. But yeah, on this video we're going to be dealing with vectors. We're going to be making our own vector class, and in the next video we're hopefully going to be delving into matrices, and we're going to be writing a matrix class. So this stream is going to vectors. What even are vectors? Well, let me just get into it. Vector. Well, vector, in the most elementary definition of vector, is that vectors are just an array of data. They're just an array of numbers, basically. Not data, they're an array of numbers. Now for us, specifically for us, it can be like since we're dealing with graphics programming, it's usually an array of floats, right? It's an array of floats. So I'll write vectors are just array of floats, array of floating point numbers. Now if we really think of this definition of vector as an array of floats, then there can be unlimited types of vector. There can be vector 2, it can be vector 3, vector 4, it can pretty much go to vector infinity, because there are unlimited numbers, right? But we don't want any of those. We don't want vector infinity or stuff. All we need is just 3 different types of vectors. We need a vector 2, a vector 3, and a vector 4. Now, to be honest, we don't even need vector 4 because we're dealing with a 2D game engine. But if in the future we think of shifting our engine into and making it a 3D engine, then we will definitely need vector 4. So might as well just make a vector 4 class while I'm doing it. Alright, vector 2, vector 3, vector 4. Vector 2, the most common example of vector 2 could be like a position on the screen, like an x, y position on the screen. 3 component vectors, the most elementary example could be like color, RGB, basically it. And vector 4, like I said, we need vector 4 for 3D stuff, where we have x, y, we have a new component z, and we have something known as w, which is a homogeneous component, which we need for translation and perspective projection. But we're not going to be dealing this because we're making a 2D engine, not a 3D engine, so this just gets scrapped out. Okay. So vector 2, vector 3, vector 4, that's what we're going to be making in this stream. This will probably be a little bit of a long stream, this might get an hour or so, but yeah, we'll just get into it. I don't care. Let's save. Let's open up Visual Studio. Like I said, this is going to be a fun stream, guys. It's going to be really fun. So in the previous streams, so we'll run the code now. We had this. We had a little illus2D engine screen. We have FPS counter, and we have boring white triangle. And we want to change that. Unfortunately, we cannot change it right now because we have to get all the mathematics and things sorted out first, and then we can finally get into it. Okay, streaming. Yeah, so basically, we need some shaders and some mathematical vectors and matrices and stuff before we can actually change it. That's what we're doing right now. I'm saying the stream. Yeah, okay, alright. For some reason, my YouTube is complaining. It's saying that it's not receiving enough streaming data. I hope it gets fixed soon. I hope. Alright, so let's just start getting into making this awesome vector library kind of thing. Hold on, is my stream going okay? Yeah, the stream is going okay. Yeah, okay. For some reason, it's saying that YouTube is not receiving enough video to maintain smooth streaming. I hope that's not an issue. Yeah, whatever. It shouldn't be an issue. Alright, so if you remember, we had created a maths folder. So we're, of course, naturally, we're going to be putting all of our mathematical vectors and matrices in this folder. Alright, I'm going to add a new file. I'll call it, we'll probably start with vector 2 for now. So vec2, vec2.h, I'll add vector2.cpp file. Get rid of this. Get out of here. CPP, I'll pin it here. Alright, cool. Let's get into it. It's gonna be fun. Class vector2. I'm probably gonna make it a struct because I just want everything to be public. Alright. So since this is gonna be a vector floats, we'll have to make it float x and y. Have a default constructor which is not going to take anything, and all this is going to do is well, yeah, I'll write the definition later on the CPP file, of course. Alright, we're going to have a different constructor. This is going to take a float x and a float y. I'll probably have some operator overloading as well, probably. So we'll do like vector arithmetic. We'll do like vector comparison, and that's basically it. So pound include vec2.h. How is streaming? My internet is slow today for some reason, that's why. Could be the reason. Alright, vec2, our default constructor. Default constructor is gonna take nothing. I'm gonna have this. Have another constructor, which is gonna take two floats, float x and float y. So basically, gonna set our member variables to that. So x to yx, y to y, and that's basically it. We'll probably make a function called void print vector, just to check everything is going okay or not. So we'll see out x fine. Put IO stream for C out. Okay, awesome. Let's just quickly check it if this works or not. We'll obviously have to include files maths vec2.h, and I'll just check it around here. Call it maths. I'll do vec2 vec. I'll give some data like 1 and 1. Vec dot print vector. Yeah, it works. 1 1. We get our vector. Nice. So that is working, which is okay. Let's get rid of this because it was just for testing purposes. Alright, so let's finally get into making our vectors. Now we want to use this print vector method. We'll probably overload the bit shift left operator so that we can directly put it into like cout function. Yeah, we can probably do that, and we'll do it, of course. Alright, vector arithmetic. Let's overload some operator. We'll probably overload the plus, the minus, and the multiply and divide. We probably don't need the divide thing operator. We'll probably don't need that, but yeah, we can do that. We can do it because we are using C++, because such an awesome language. We can. Alright, let's just get into it. It's gonna return a vector 2 operator plus, and it's gonna take another vector 2 by reference, of course. We don't want to copy it. We'll do it for minus, multiply, divide, and no, not that one, yeah, this one. And we're also going to be multiplying with the scalar, so we'll do const float left and scalar. Yeah, this basically, yeah. Cool. Let's just implement these methods into our .cpp files. Vector comparison, we're going to be overloading some more operators here, probably the equals and the not equals for now. Yeah, those are probably what we're going to be overloading, but we'll take care of this later. We'll first implement these functions, and then we'll get into the vector comparison. Alright, vector.cpp, operator plus vec2, it's going to return vec2, vec2 operator plus const vec2 reference vec, copy it, paste it multiple times, subtract, multiply, divide, and we'll just get this one over here, I believe. Yep. It's gonna be multiply as well, but with a scalar. So const float reference scalar, and this one a scalar as well. Const float reference scalar. Awesome. Awesome. Yeah, it should be okay. So plus. So how will we tackle this plus operator? Well, it's pretty simple. Just return a new vector, a vec2 with its components added. So vector addition is, I hope you guys know some of the linear algebra, like how vector additions work, how vector subtraction work, and all this stuff. I will probably not go into the details because it's just like basic high school mathematics. I hope everyone knows it. So yeah, so vector addition is really simple. It's like the addition of each component. So x component of one vector with x component of another vector, y of one with y of another, z with one, z of another, and yeah, that's basically it. So it's pretty easy. So all we do is do x plus vec dot x, and then we do y plus vec dot y. So it's just component wise addition. It's really simple. And yeah, this is basically it. We are using vec2, and it should be all we need. Cool. Copy this, paste it here, paste it here, and paste it here. Subtraction, we of course need the subtraction sign for the vectors. Multiplication, multiply this. Division, divide this. For scalar as well, for scalar it's really simple. We'll scalar multiplication, just so we can multiply this with our scalar. That's pretty much it. This with our scalar. We're gonna divide it with our scalar. Cool. Yeah, should be enough. Should be enough. Should be more than enough. Yeah, awesome. Now let's just check it if our vector arithmetic works or not. We have included vector. Maths vec2, call it A. I'll give something like 1 1 1, something like B. Oh, I'm giving 3 values because I'm just used to working in the 3D space, because I usually write like 3D scenes in OpenGL, so yeah, it's just a bad habit. Okay, vec3, no, vec2 result. Okay, A plus B, awesome. So yeah, result. And now of course we can't do that right now because we don't have the bit shift left operator overloaded yet, which will do. For now I can just do result.x, and I can probably do something like this, result.y, and check it. Hopefully we'll get 2 and 2. And we do get 2 and 2. Awesome, it's working. Vector addition working. Now let's try vector subtraction. We should hopefully get 0 0. You get 0 0. Awesome. And can just do. We can check everything if you want. Try with this. Go 1. Division. Division is 1 1. Awesome. Let's try multiplying with the scalar. Let's multiply A with something like 10. So we'll hopefully get 10 comma 10, and we do. Awesome. This, and it should hopefully work with floating point number as well, and it does. Cool. All right. Yeah, that's basically it. So vector arithmetic works. Awesome. You know what? I'll probably put this in a namespace. So yeah, I should have done that earlier, but I had not. I'll put it on a namespace. Of course, the illus2D namespace. It's going to be the first one, and of course, the next one is going to be our maths namespace. So namespace, maths. Going to be cutting this, pasting it here. Copy this. Put it over here because our thing is going to complain. This. Awesome. Cool. Of course, here we'll have to use the namespace. Maths using, not unsigned, using namespace maths. Great. It works. Yeah, it works. So let's just try to do like let's just overload the bit shift left operator, so that we can like do this instead of doing x dot y. We can just do something like std cout results. Bam. Of course we can't do it right now because we have an operator overloaded yet, but we'll right now. So outside this struct we'll do std. I believe it's an O stream. Yes, for the output stream. So O stream reference should be a reference. O stream reference. The operator bit shift left. We're taking a const vec2 reference vec, and I could probably just define it right here if I wanted to, but yeah, we'll just do it. It's giving me an error for some reason. Oh yeah, of course I'll also need the stream for the actual stream. Vector.cpp, I can just do it out here, I believe. Stream reference std operator this stream vector, and all we're gonna do is just gonna push it to the stream. We're gonna push vec.x. So let's just make it a bit neat. So we'll do a bracket vec dot x, we'll do a comma, vec dot y, we'll do this. We'll not have the end line, and we'll just return the stream. So this is going to just push this to the stream. It's going to push it, it's going to display on the screen, and it's going to return the reference to this stream. Because we are returning a reference, that's why. Awesome. Cool. So now, hopefully, this is going to work. This should work. And it does. It does. Awesome. It does work. It does work. Cool. Let me get rid of that. Nope. That. Okay, yeah, nice. Let's just do the comparison operators. So comparison operators are like, so if like this vector is equal to this vector or not. So for example, I can do like if A is equal to B, and I can do like return or something, stuff like that. So yeah, we'll see like that. So if A is equal to B, we can return, and if it is not, we can do something like not equal or stuff. Yeah, just like that. It's actually pretty easy as well. So if you go to the vector class, you can do something like boolean, because it's going to return a bool. So this is the function. It's going to take a vector, and it's going to return a bool. So one trick is like operator overloading, to be honest, can be a bit it can be a bit confusing for beginners. The way I actually learned it is I actually thought like my teacher said that think of operators as functions. Okay, so for example, so this is the function, so it's called, so this double equal is a function. It's going to take two parameters. It's going to take A and B, and it's going to return, this whole function is going to return a bool. So in this way, if you think of an operator as a function, it makes it a lot more simpler and easy to understand. Okay, so think of operators as a function. That's basically what I want to tell. All right, bool operator equal. We're going to be taking another vec2 by reference. Call it vec not equal. That's basically it. To vector arithmetic. Comparison. Alright, let's get into making the function operator. It's going to take a const vec2 reference to a vector. Of course, it's in the vec2 class. Of course, need that. So basically, what this is going to do is going to return true if these two vectors are equal, and false if they're not equal. It's basically some. So if we can check like x is equal to the vec dot x, and y is equals to vec dot y, and z is equal to vec dot z, then we'll just let's give it not z. I have this habit, like I said earlier, of working with vector 3 so much that I write z and w everywhere. Okay, so if x is equal to vector x and y is equal to vector y, I will just return true. So these are equal. So if they are not, we'll return false. Okay, so copy this, paste it around here. Not equal. So if these are equal, we'll return false in this case. If they are not equal, we'll return true in this case. Awesome. So let's just check it again. Yeah, so if A is equal to B, we'll do something like equal. Always they are, so hopefully we'll get equal printed to the console. Yep, we get equal. And let's change this to be 5, so hopefully get not equal. Yep, not equal. Awesome. Awesome, it works. That's basically what I want to stress. It works. It damn works. Alright, vec2, pretty much this. Alright, so we have the vector comparison, and I'll probably get to it. So we have the vector comparison, and vector arithmetic operators sorted. So now we'll probably get into the advanced arithmetic. So vector arithmetic, vector advanced vector arithmetic. So this is basically going to contain something like the dot product of vectors, cross product, and something like and I also want to when I have some functions like get magnitude or like get length of the vector. It's pretty easy to do, and we'll do something like normalize to make it a normal vector. Oh yeah, we have a lot of stuff to do. Holy hell, man. So cross product, dot product. I'll probably just make the function right here. So with the void, so we're gonna float, get length of the vector. This we'll just yeah, get length. We'll do float, normalize. This is probably gonna be like void normalize, or it's gonna. Or yeah, we can just do like vector 2 get normal vector. Again, like a normal vector of length 1. That's basically it. So normal vectors are just vectors that have the same direction but have the length as 1. That's basically what a normal. That's basically what a normal vector is. All right, vector.cpp. Again, yeah, we'll just do here void vec2 get length. It's not void, it's float. So for this, so the length of the vector is just the Pythagorean theorem. It's basically all it is. So get paint here. So if you have a space like this, it's pretty bad. We have our space. We have a vector here. It's an x and y. So it's from the origin to this. So this is a vector. The length of the vector, which is basically this length, is actually it's actually really simple. All we do is Pythagorean theorem. So we just go x unit here, y unit here. So it makes it a right angle triangle, and it becomes the hypotenuse. And hypotenuse is over x squared plus y squared. That's basically how we get the length of the vector. All right. So for this, I'll probably need to include like C math probably. I'll just include it here. Include C math for the under root. So here I'll just return a. I'll do so float length is equals to square root of the x squared plus y squared. That's basically all it. I don't even need to create a float. I can just return this. That's basically it. We have another function called vec2 get normal vector scale. We'll just do stuff like to get a new normal vector. So normal vector is actually also really simple. All we need to do is just divide the vector with its magnitude. So we divide the vector with this. That's how we get a normal vector. So we have the get magnitude function. So all we need to do is make a new vector. So vec2 normal vector. We'll do normal vec dot x to be the x of the current object. We divide it by get length. Split. So y. We do y divide by get length. Yep. And we'll return normal vector. That's it. And also I'll probably make a new method. I'll make something known as a normalize. So void normalize. I can just make it return the. Well, yeah, I can just do vec2 normalize. I'm not sure if this is gonna work or not. I'll just check it. Normalize. So we're just gonna return a reference to the current. So we'll just do x equals x divided by get length. So we're just so I'll just explain why I had to make these two different functions, get length, and we'll return a reference to this. So alright, so the reason why I had to make this two function because this get normal vector is going to give me a new vector. So if I have a vector and I call this get normal vector with that vector, it's not going to change the original vector. Okay, it's just going to give me a new vector, a new normalized vector. But this normalized function is basically going to normalize the current vector. So the vector that I used to call this method, okay, so the vector that I used to call this method is going to get normalized. So that's the difference between these two functions. All right, normalize. That's that's basically it. All right, vector arithmetic. We'll get into advanced. It's not really advanced, but whatever. Advanced vector arithmetic. For that, so alright, so basically what we're doing in the advanced vector thing is we're taking the dot and the cross product. That's basically it. And yes, I'll put it on here. Dot and the cross product. So for that, so dot product of vectors is, I'll probably explain it again. So let's say you have two vectors. Okay, so let's say you have two vectors. So you have a vector A, which is like x and y. So x1 and y1. Vector B you have is x2 and y2. Dot product is pretty simple. Dot product is A dot B is denoted as we multiply with this component. That's basically what it is. We multiply with this x2 and then we add it to it. So y1 times y2. So dot product gives us a scalar. Okay, so dot product of two vector gives us a scalar, and this is the formula. It's pretty simple as well. We'll do so it's gonna give us a scalar, so we'll have to return float. Let me just make the definition of the declaration of the function before we write the definition. Float, call it dot, some name. So taking a constant vector 3 and should be vector 2. Copy, and I'll also make one for the cross product. Now, we probably don't need cross product for 2D vectors, because, well, if you know what cross product is, a cross product gives us a third vector which is perpendicular to the two vectors that we used to get the cross product. So if we are working in 2D, we don't really need the cross product. All we need is the dot product. So we're not going to be doing the cross product here, but in the vec3 class we of course have to do the cross product. Alright, vec2 dot, also name, constant vector reference, vec, and I'll just return I'll return x. I'll return a vector 2 with x, not a vector 2. What am I doing? It's going to return a scalar. It's going to return a float. So I'll do x times vec dot x plus y times vec dot y. That's basically what we do. Yep, our dot product function is done. Now, should be this. Yeah, it's pretty much done basically. This is our, we have 99 lines of code. One space, bam, exactly 100 lines of code. So that's looking pretty good actually. We don't need anything else more than this. We'll probably just set this thing to 0 actually. I forgot to do this. Okay, x and y, look at the length, take the square root. Get a normal vector. We normalize the current vector. I think we should have to take a reference actually. they are particularly cool. Like that. Yeah, let me check it actually. We don't want to hurry anything. Get rid of this. So std, let's do it. So the results dot get normal vector. So let's check with length, get length. Actually, let's check get normal vector. Yeah, so we get a normal vector, and hopefully if you take the magnitude of this vector, so if you take the length, hopefully we'll get 1. So that's the one sure way to check it, and we get 1. Awesome. So it is indeed a unit, a normal vector, a unit vector. Okay, check another function. Get normalize. Yeah, we get the same length. We don't get the same. So of course, let me go here, x times this to get length. I don't see the issue here. I don't see what's wrong with it. Is it because we're returning a reference or what? Nope. Still get there. We still get that error for some reason. So what's the normalized? Okay, we get that. It's pretty bummer. Got okay, normal vector. Okay, normalize it. It should be the same. Hold on, let me am I doing something wrong here? Get normal vector is going to return a vector 2. Let's do that, return that. X equals x times by the length. By the length. Hold on. Results get length. So the length is 14.89. Okay, so this is the actual length. Now if I go to the normalize, and if I print the get length from here, hopefully we should get the same. And it says get length is undefined because probably that. Okay, so we get the same length. I wish to get the switches code, so it's okay. For some reason, x value is not changing. All right, so let's say bummer. X times get length. Yeah, that's pretty weird. That's really weird. Okay, y equals y divided by length. X equals x divided by length. So let me just see what the x and y values are. And then we'll finally get to this. So x. Print the x and y values here, and the normal vec.x, the normal vec.y here. Okay, so this is the magnitude of a vector, get length, and this is for the normalized vector, so this is that. This is the y, so the y for some reason does not get divided by the get length. Okay. That's pretty weird, I don't know why. Yeah, I'll just probably I'll probably fix it later, I guess. Yeah, I'll make it to do fix this function. Okay, I'll just later. All right, normalized. So I'll get normal vector. I'll get rid of these. I'll get rid of that. Whoa! Just cut rid of my stream. Let's press something else. So the get length oh, I think, oh my god, I think I get the error. I think I do. Hold on, let me just check. Float get length. Let me just do this first, and let me Control C, Control V this. I think I get the error now. So normalized. Oh yeah, it's fixed. Holy hell, man. Get length. So the error was actually kind of. Hopefully we get 1 now. Yeah, we get 1. Awesome. So the error was actually. Oh yeah. So the reason why it was doing so, okay. So the reason why it was acting on weird. So we did the get length here, right? So we had this code before. So let me just copy this. So we had this code before. So what was happening is that the x. So when we called the get length function the first time, the x value was the same as it was before, but this time when we call the get length function, the x value actually changes because we are modifying the actual x value here. Okay, so that's what's happening. So I had to make a separate variable called length. I had to calculate everything at the first, and then had to do it. So yeah, it was. Let me get back to what I was. Cool. Let me run it. Yep, it works. It works beautifully. I love it. You love to see it. And I can. And if I do this code after this, hopefully. Yep, we get 1. Awesome. So this function actually modifies the actual object. That's what I was trying to test. Okay, so this is basically our vector2 class. It's awesome. It's done. Let's just get into vector 3, I guess. Let's just get into making the vector 3. I'll add another file here, maths, add new item. I'll call it vector3.h. Add vector4.h. It shouldn't take too much time because not vector4. Vector3.cpp. Vector3.cpp. And literally what I'm going to do is, since most of the code is going to be the same, I'm going to copy it. I'll paste it here, and I just accidentally press B, so it builds. I'll copy this as well, all of it. I'll put it over here, and now let's begin changing. So we'll change okay, so vector 3, of course we need another component. We need the z. We'll take in float z, operator plus. We'll take everything's gonna be same. This is gonna be same, and we'll make a for the cross product. So vector compare is gonna stay the stream same. The stream is gonna stay the same. Awesome. So let's just modify the class. So y z, make a 0. Z, take the z. Take the flow z. Float z. Say giving me an error. Vec2, of course we have to change it to vec3. Of course we'll change it to vec3. We can probably do a find and replace match in the current document. I'll replace find vec2 with vec3, replace all 38 occurrences, current document, yep. Get rid of this. So vector 3, vector 2, I have to do this on here as well, so control shift F, place vector 2 with vector 3, all, and yep, most of our error has been minimalized, and we'll have to okay, so let's get into setting this up. Vector 3 is awesome. Alright, so z square root, we have to add another component, so z times z to get the length. The normal vector, we have to divide the z as well, the length, and we'll have to do to get length, so z is equal to z divided by the length, which is reference, and we'll have to add z plus vec3 dot vec dot z. Let me copy this real quick, paste it here, subtract, paste it here, multiply with the scalar. We'll just do z times the scalar. So divide, we'll do this, and for scalar we'll just divide it to the z by the scalar. Pretty much it. That should be pretty much it. And for dot product, we'll of course have to add z times vec dot z. Okay, comparison, x equals to vec dot z equals to vec dot z to dot z. The stream will have to of course print vec dot z. Cool, pretty cool if you ask me. That's pretty much it. So we added the plus operator, subtract, multiply with the scalar, divide by the scalar. And for the dot product, we do that. Comparison, compare z, true and false. Okay, so let's add the cross product. So float vec3 cross, taking a const vec3 reference called vec, and yeah, it's been well over 50 minutes since I've streamed this. Probably gonna be hitting that 1 hour mark. So cross product of the vector. Now I will definitely have to take out the spring for this cross product of two three-dimensional vector. Now this is a bit conceptual. So let's say if I have this one vector, I'll call it A1, A2, A3. I have another vector, I'll have B. So B1, B2, B3. Okay, so the cross product. So cross product of these two vectors. So conceptually, what cross product is if you take the cross product of two vectors, the third vector, the actual cross product, is going to give you a vector that's going to be perpendicular to both these vectors. Again, cross product are really important, not actually for us because it's not that important for us because we're doing a 2D engine and we're rendering 2D stuff, but if we were to do 3D in the future, this will be very, very important. Okay, so we want to have the cross product thing for now. So the way you take it is actually by using a determinant rule. So we take the determinant, this, so A cross B, take the determinant, so we put x, y and z here, A1, A2, A3 here, B1, B2, B3, and basically take the determinant. Now if you taken your high school mathematics, you'll know that to take the determinant, first you take the x. I don't think I'll have this enough. So take the x, you'll get rid of this, and you just multiply these two together. So multiply these with this, minus multiply this with this. So it will be A2 B3 minus A3 B2. So the first one is going to be this, and then plus, and not plus. So you can take minus, and you multiply with this. So it's going to be A1 B3, of course the y, A1 B3 minus A3 B1, and you get the drill, and you just do plus here. So you plus minus plus, you'll do with this. So z, have multiply this with this, minus multiply this with this, you have A1 B2 minus A2 B1. That's basically how you take the cross product. Now I believe I have a folder, so you can see it's a bit cluttered. I cannot really understand what this I have wrote myself. So I have a picture that I downloaded from the internet, which shows beautifully how you take the cross product, which is basically this is the way you take cross product. Vectors. Okay, so this is the cross product right here, the image I was talking about. So yeah, this is how to take the cross. So we have this vector, so A2 B3, A3 B1, yeah, that's basically it. So we'll just implement this into our code. We'll take the cross here. This is not going to be a float, it's going to be another vector now. So vec3, and I put my other minor for some reason. So vec3, it's going to do, supposed to make a new vector. So crossed, I will return crossed, and then we'll just begin doing it. So for the cross.x, we'll do so A2 B3. So I have this right here. So A2 B3. So it's basically this is going to be, so y, so A is the current vector and B is the vector that we're taking in from the parameter. So it's going to be y times vec.z. So y times vec.z plus minus, my bad, minus going to be z times vec.y. So z times vec.y. Okay, and we'll copy it multiple times. Cross.y, cross.z. So y, we're going to have a negative sign. Be careful of the negative sign. So we'll do negative. It's going to be a1 b3. So it's going to be x times vector z. So x times vector z minus minus x times vector z minus going to be vectors. No, it's going to be z times vector x. So z times, actually no, yeah, so z times vector x. Cool. Then we'll have x times vector y, x times vector y minus have y dot vector x. So y dot vector x. It's basically how you take the cross product. And b3, so we'll quickly check it. So y times vector z minus z times vector y, x times vector z minus z times vector x, so x to vector y minus y to vector z. Yep, looking good. Don't forget the thing here. Don't forget the brackets. It's important. It's important. Don't forget the brackets. And yeah, it's basically, yeah, that's basically how we're taking the vector cross product. We'll of course have to check it. Okay. Cool. Yeah. So this is basically our class. This is basically our this is basically our vec3 class. Everything is well. And we just check our vec3 as well. So go to main. We'll include #include files slash math slash vec3.h, and here I'll get rid of vec2 stuff. Vec3, A, I'll call it 2 3. B, I'll call it 2 4 6. I don't even know why I did that. Okay. So let's check vec3 result equals A times B build there, of course build there. Okay, what do we have here? Unresolved external symbol. Reference in main. Okay, we're getting a linker error for some reason. This is a reference in main, reference in function main. Okay, yeah, I think it's Pythagoras freaking out. Vector 3, we have this outside. It takes in a vec 3. We have a vector 2.h. It's also outside. It takes in a 3, vector 3. So vector 2, vector 3. It shouldn't be an issue. I'm not sure why is it complaining. It said it takes in a vector 3 here, it takes in a vector 2 here. Should be fine, I think. Should be fine. Oops. So vec 3, so math vec3 vec3. So we're getting error from a vec3 class, of course. That's all I know for now. Maths vec3 flow. I think it's pointing to the constructor referenced in function main. Okay, so operator plus reference in function main. And then we have the O stream operator. Like, look at this, like, oh my god, look at this error code, like, tells nothing. That's why C++ is really hard. It's not a language for beginners. Like, look at this error, like, it makes no sense. Like, of course I know it's a linker error because say lnk, which in first case isn't even that explicit. 3 unresolved external. So the operator plus that operator and the case. So okay, let's just begin debugging. H, we have plus operator takes in vector 3 reference, and operator takes another reference to vector something. Yep, I mean, this is a bit weird. It's a bit weird for some reason. Well, let me just let me Google check this. Stack. Let's check it here. An actual symbol referenced in main, I guess, referenced in function main. Referenced type def. The main method. I'm confused. I don't think that's our error, to be honest. I think that is our error. Yeah, for some reason it says it can't find it. Pragma 1s, we have all the Pragma 1s. Yeah, that's a really weird error. Main function. You need I have a main function. What do you mean? What do you mean? It's not a main function error. So let's check the second one. So operator plus, this call operator plus struct illus2D referenced in function main. Okay, just copy all of this, why not? Yes, oh yeah, so all these are same. So it has already been mentioned in reference main. That's what it's trying to say, I guess. Check this. It's all about missing the patch. Check this. In main function, okay. Referenced in function main. Stack Overflow, I think I have been here before. I have a main function, what do you mean? Okay, let's just this is really weird, okay? It works that way. Okay, so referencing function means, so this is I think I cannot find the definition. Hold on. Hold on a second. So they cannot find the definition. Well, there is the definition. There it is. The definition is right here. Let me just build this file. Failed. Control F7. Build this file. Just. I think I cannot find this file, I think. h3.cpp. Looks like for some reason this cannot find the file. This thing cannot find the file. The linker cannot find this file. Hold on, let me just. Sometimes it happens actually. Sometimes you have to restart it. I think I know what the error now is. It cannot find the functions. It cannot find the functioning. That's the problem. Let me compile this now. Control F7. Control F7. So this builds. Okay, this builds. So you do get an obj file. So, but you don't get an obj file with vec3.cpp. That's really weird. That's really weird. Included maybe. F7. Not this. F7. Hold on, let me see if we have the obj file or not. Because when C++ compiles, it creates an obj file. We can just check if it has that obj file or not. Debug. So vec2 3D object, just array. Okay, so it has the obj file. Oh wait, it has only the vec2's obj file for some reason. So it has a main obj file, the index buffer, vertex array, vertex buffer window, but it does not have the vec3 obj file for some reason. It's really weird. It's really weird. Damn. Did this compiled? Did it just compile? File is compiled. Wow. Oh my god, that's a very bad bug, guys. That's a very bad bug. I'll probably have the obj file now. Do we? Yep, we have the obj. For some reason it wasn't compiling. For some reason it wasn't compiling. Holy hell. For some reason, look, this wasn't our fault at all. This wasn't my fault. This was the compiler's fault. Your teacher might say that the computer is right 100% of the time, but no, see, in this case the computer is not right. The computer didn't even compile my file. It didn't. Look, I have video proof. Right, I have video proof. I caught it on tape, guys. So yeah, this file right here, it wasn't there before, right? But when I physically got inside and I restarted my Visual Studio, it was there now, which means, oh my god. Yeah, whatever. So yeah, so our thing works. So that's the number 1 point. So it works. We get 369. Let's just check. So results dot, we can do something like dot, we can dot this with a, we can solve that. Now I just want to check the cross, see if this works or not. Okay, so we get that, which is weird because say different vector. Okay, now we should get something. So we get that. If I just dot it, result, what do I get? I get 0. Awesome. So it makes sense because, like I said before, if you cross a vector, so if you take the cross product of two vectors, we get a vector that's perpendicular to both those vectors that we used to cross. So, and if I dot it with the one of those vectors, we should get 0 because the dot product of two perpendicular vectors is 0. So our functions are working pretty well. So that's it for today, guys. It was a very long stream. We tackled vector 2s, vector 3s. We didn't do vector 4 because we don't need it. We legitimately don't need vector 4s, which are just vector 3 with one W component, homogeneous coordinates for translation and perspective projection in the 3D space. We don't really need it. We're doing 2D stuff. In the next video, we'll probably work with some matrices. We'll probably write our matrix class, and actually I'll probably make a new folder here. I'll call it data buffers, and I'll paste all of these right here. I really want to organize my code. Yeah, I'll put it right here. Go to main.cpp. I'll have to do graphics, data buffers, data buffers, whoops, data buffers. I have to do something like that, and still it's not gonna, of course I'll have to do this probably. Data underscore buffers. Oh, I'm so stupid. I should be doing okay, data buffers. This right here. Graphics slash data buffers. Copy this, paste it here. Sit here, data buffers, vertex array. We have all of this. So we have organized it well. Run the code. Hopefully it runs well. It should. Yep, it runs well. We get 0. Let's get rid of that 0. Actually, I'll just keep it here. It's just for testing. I'll put the namespace up over here probably. Yep, I'll put it over here. Studio namespace maths. Testing maths. And yep, that's basically it. Also, I was actually going to tell you, I actually have a GitHub page. GitHub.com. I have a GitHub repository here. I'll link it on the description after I upload the stream. And I will also push these files into my GitHub page so that you guys can download my code and kind of like tweak it on yourself and see how the engine is going well. Yeah, that's basically it. I'll just upload it to GitHub right now after this stream, and I'll leave the link down below. Yeah, this much for this stream. Next stream we'll work on matrices, which should be awesome and also a bit complicated, but we love complication. We love things that are complicated because we get to learn it. We get to learn a lot more stuff. And matrices are actually really conceptual. It's like more than twice. It's double the concept than the vectors. So if you think vectors are hard, matrices are really gonna be testing your math skills. Alright, so this much for this stream. I will just see you guys in my next stream where we're gonna be tackling on matrices, and we're gonna finally take a break from mathematics and probably get into like shaders and then text. So we'll do matrices, and then we're probably gonna get into shaders and then some textures. And then we still have some other, and then we'll probably have to make a camera system, like an orthographic camera for our 2D game, and then we'll get into lighting. Oh my god, there's so much things to do. Yeah, that's basically it for this stream. I'll see